Welcome to another explainer. Today, we are looking at an absolute behemoth of the universe. I want to introduce you to Caldwell 35, also known to astronomers as Coma B or NGC 4889. Located around 300 million light-years away from us, in the Coma Berenices constellation, this supergiant elliptical galaxy in the Coma galaxy cluster looks, well, pretty calm. At first glance, you might think it's just a perfectly smooth, maybe even slightly boring, dead orb of ancient stars. But looks can be incredibly deceiving. Beneath that serene, glowing exterior hides a violently dynamic history of cosmic collisions, devoured worlds, and a supermassive black hole that is still very much awake.
Okay, let's dive into this. When we look at the core of the Coma cluster, that massive, bright smudge of light dominating the view is our subject, Caldwell 35. But instead of just admiring its glow, we're going to treat this galaxy as a cosmic crime scene. We are essentially performing a full scientific autopsy to figure out exactly how this giant got so incredibly massive, what it ate along the way, and what is currently keeping its heart beating.
So here is our cosmic forensic ledger for today. First, we'll meet the cosmic giant. Second, we'll track down the chemical footprints in its stars. Third, we'll search for the shells of a devoured world. Fourth, we'll check the giant's beating heart. And finally, we'll explore its restless galactic neighborhood. Let's get right to it.
Section 1. Meet the cosmic giant. Caldwell 35 is what astronomers call a brightest cluster galaxy. It's an undisputed heavyweight, sitting right in the densest part of the Coma cluster. Because it's so massive, understanding its history is basically understanding the history of the cluster itself. Section 2. Chemical footprints in stars. To read the fossil record of this galaxy, astronomers used deep spectroscopy from the Subaru telescope, and they were able to capture chemical signatures incredibly far out, up to 60 kiloparsecs from the very center of the galaxy. So the crucial point here is the stark contrast that emerges between the galaxy's inner core and its outer halo. Inside a radius of 18 kiloparsecs, the core has a really steep metallicity gradient and a surprisingly high ratio of alpha elements, things like oxygen and silicon, compared to iron. But out in the halo, from 18 to 60 kiloparsecs, that changes. The metallicity is near solar, and the alpha to iron ratio drops off sharply. What does this actually mean? Well, this juxtaposition proves the galaxy formed in two very distinct phases. The inner core formed through a rapid, violent collapse way back early in the universe's history. But that outer halo, that was built up much later. It slowly accumulated through what we call dry mergers, which is essentially Caldwell 35 swallowing up other older star systems over billions of years. Section 3. Shells of a devoured world. Think about it. If Caldwell 35 grew by eating other galaxies, shouldn't there be crumbs left behind? Let's look for that ghostly substructure. What astronomers actually found using the Hubble Space Telescope was the unmistakable signature of a minor merger, a mass ratio of 90-1. Think about the sheer scale of that number for a second. This wasn't two equal titans clashing in space. This is literally a massive blue whale swallowing a small fish. Specifically, a moderate luminosity disk galaxy wandering just a little too close, only to be completely shredded by the intense gravitational pull of Caldwell 35. And this brilliantly illustrates exactly what that cosmic meal left behind. By mathematically subtracting the smooth, blindingly bright light of the main galaxy, scientists revealed 4 distinct, faint, arc-like stellar structures. These are called shells, perfectly aligned with the major axis of the host galaxy. These shells are literally the stripped-off stars of that much smaller victim, now just oscillating back and forth in the massive gravitational well of the giant. They're actually bluer than the surrounding stars, making them a permanent, glowing fossil record of a devoured world. Section 4. The giant's beating heart. To see what's happening at the center right now, we have to swap to X-ray vision, looking at deep data from the Chandra X-ray Observatory. Now, what's really interesting about this X-ray glow is that the very center isn't uniform. Right in the middle of this intensely hot X-ray emitting gas, there is a distinct depression. It's a cavity, a pair of hollowed-out bubbles with a radius of about 0.6 kiloparsecs. These bubbles aren't just empty space. They act like the beating heart of the galaxy. In fact, this happens to be the smallest and youngest known cavity ever found in a brightest cluster galaxy. It was carved out by an outburst from the supermassive black hole at the center. As the black hole feeds, it jets out energy, pushing that hot gas away.
The maths tells us this cavity contains an unfathomable amount of energy, an enthalpy of 5 × 10 to the 55 ergs. But crucially, this energy isn't violently overpressured. It represents a gentle heating, a slow, rhythmic breathing that prevents the surrounding gas from rapidly cooling and forming new stars. The giant is alive, and its heart is gently pulsing.
Section 5. A restless galactic neighborhood. We've looked at the giant's core and its heartbeat. Now let's zoom out and use S-tree analysis to see what it's doing within the Coma cluster itself. This analysis absolutely shatters the illusion that massive galaxies just sit completely still in the center of their clusters. It turns out Caldwell 35 isn't stationary at all. It actually belongs to a specific, distinct group of 14 galaxies known as subgroup 2s. And this entire subgroup is dynamically moving, actively plowing right through the main body of the Coma cluster. This giant is literally cruising through its neighborhood.
Which brings us to a really fascinating final thought. When we first looked at Caldwell 35, 300 million light-years away, it appeared to be a featureless dead relic. But by acting as cosmic forensic scientists, using spectroscopy, residual modeling, X-rays, and kinematic mapping, we uncovered a completely different truth. We found a galaxy forged in a rapid early collapse, one that spent billions of years devouring its smaller neighbors, harbors a gently pulsing supermassive black hole, and is physically migrating through its local cluster. It's a living, breathing, evolving monster. And it really makes you wonder, if a distant fossil like this is hiding so much dynamic chaos, what kind of incredible secrets is our own galaxy, the Milky Way, hiding right under our noses? Thanks for joining me on this explainer, and as always, keep looking up.